I was playing this the other day and it got me thinking, how would I design a game like that? Then I made a quick prototype and realized there are many things I can teach you guys. So, making this tutorial. Now, I'll end the video when the mechanics are ready and leave the fine-tuning to you in case you're feeling creative. I'll accept submissions on GitHub or Discord and make a video where I showcase all of them. I'll also choose my favorite and add a special feature to it as well. Sound good? Alright, now get ready for a lot of twists and turns. Get it? Because the ball is... No. Gonna code, debug and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. Before we begin coding the game, I want to show you something. If you go to the virtual world repository from the self-driving car course phase 2 and open integration, you can go inside of the world editor, so this index.html right here, and you will get something like this. And in that, you can draw, for example, a zigzag pattern like in our game that we are trying to make. So something like maybe this, and this, and this. And you can make it as long as you want. I'm just gonna stop here. And then you can add the car at some location, maybe here in the beginning. Let me zoom out a little bit and save this file. I'm not gonna save it anywhere on my computer. I just close this box that comes up because it's gonna save in local storage. And then outside of this world folder, open the other index.html here, and you'll see this crazy thing, but we don't need this advanced stuff. So no AI driving cars. I'm going to go to this main.js, reduce these to just one car, and then on line 58, replace AI with keys so that we can control it with our keyboard. If I go back here and refresh, now I have control over the car like this. I could drive on this path with the keyboard, apparently not doing a good job. But anyway, it's not yet the game. For that, I'm going to open the console here and paste this code. So I just have a direction equal to 1 and a pointer down event listener on the canvas, and it changes the direction from 1 to -1, and then the best car angle, which is the car that we have right here, increases with half pi, so 90 degrees multiplied by this direction. So it either goes like that or like that or like that or like that. And now if you're going to play the game by pressing up and clicking on the screen, it's pretty much the same game that we are trying to implement using the code base from the self-driving car course. So this is an example how you could use libraries to make a game like this, and it's really easy, really straightforward. The problem with that can be that, well, there is a lot of stuff happening here. Like we can have any kind of roads in this environment, and these polygons are rounded here, and the collision detection is not very efficient. So all that would translate, if you make a mobile game, for example, in very fast draining of the battery. Because even though this works just fine, it uses more resources than you could do implementing that game from scratch. And it's just an example where using some existing code to build something else gives you some nice things. Like this definitely looks unique, and it's a nice idea for a game, maybe. I don't know. It also brings some unwanted things because this library is made for a very general purpose, and the methods in it are quite advanced and quite general. So in the application we are trying to make, I basically see circles and rectangles, and collision between that is very easy to detect. It doesn't involve sophisticated math like here. Having said that, some libraries can also be very good. Some of them are so robust that they have specific cases for collision between different kind of objects there, and they might have the circle rectangle collision if they see that it's a circle and rectangle there in the environment. So I'm not saying it's bad to use them. I'm just saying that if you do use them, make sure you know what you're using and read the documentation. Anyway, now let's begin with our project. So I'll be using Visual Studio Code, and in an empty folder, let's create our first file, index.html, and specify the doc type and the HTML tag. Let's close it, not to forget, and the head tag and the title, Zig-Zag game. Now in the body, I'm just going to define a canvas element like this, and let's open index.html in a browser to test. I'm using Google Chrome, and the title appears here at the top, and the canvas is actually here. You can see it if you open the developer tools and this elements section. You can see the canvas appears highlighted there. It's just transparent. Let's make it visible. I'm going to give it a style here, inline, background color. Let's try coral, like this. Save, refresh, and here it is. It's visible now. And now I'm going to make this fill the whole screen, and it will be dynamic, so it fills every screen. And for that, we need to use JavaScript, and also I'm going to need to refer to this canvas in some way, so I give it an ID. And in the script tag, I will set my canvas's width to the window inner width, and the canvas height to window inner height. Now if you save and refresh, you see that it does fill the screen, but these scroll bars are also here. They don't look good to me. So the reason they appear is because this body has some extra margin, and we can remove that with some CSS here, setting the margin to 0. And then they disappear like that. But the scroll bars are still persisting somehow, so we can remove those by writing here also overflow set to hidden. And now I got what I want. Let's try the canvas out by drawing on it. So I'm going to get a reference to the drawing context of the canvas. And let me just draw a rectangle using stroke rect at 100, 100, the top left corner, and with a width of 300 and a height of 200. And there it is. So the canvas seems to work. And now we can think about that track where the ball is going. I want to draw this track not in that kind of zigzag fashion that you see going upwards, but starting with a horizontal rectangle and then vertically going down, and then horizontal and vertically going down. You'll see how we convert it later with some rotation trickery, but basically keeping axis aligned rectangles like that will make a very easy and very efficient collision detection system. So we begin with that, and then we make it look like the actual game. Now I'm going to start by writing here at the top some properties that our rectangles will have. I'll just keep them fixed with a short side of 50, a long side maybe 150, and let's generate 10 rectangles for now, starting at the top left corner. So I'm just going to begin with an X at 0 and Y at 0, and we're going to change these in a loop. I want to start easy and just generate rectangles one after another in a row. And for that, I'm going to go down here and write a simple for loop from 0 to n. And let's be clear in the code, and I'm going to take out the width and height from the long side and short side that we have defined here at the top. And using these, I'm going to stroke rect. Instead of these hard-coded values, we have now the X and the Y, the width and the height, like so. Let me align this a little better. And now, every time we do this, we can increase the X by the width. And let's close this curly brace, save and refresh. And you can see now rectangles generated one after the other. But we want the second rectangle to go downwards. So the long side and the short side should flip so that they become the height and the width respectively for this one and for this one and for this one. So if it's even, if the remainder when dividing by 2 is 0, then we do what we have been doing so far. Otherwise, I'm going to copy this and change it a little bit. So the width and height become short side, long side this time. And then the Y value, so this one from up here, increases by the height. And now if we save and refresh, we get this, which already looks like what we are trying to build, except for that rotation thing that I said we can fix at the end. You can even do it in CSS, like maybe go here and say rotate 45 degrees, and now it looks like that. But it's not ideal. We are going to do it with context methods. Anyway, we know how to draw the track now, but drawing it like this is not enough. We should have control over the rectangles so that we can check if something is inside them or not. And for that, we're gonna have to use some kind of object. And I'm gonna start to use external JavaScript files now because this is starting to be a bigger project and it definitely needs them. So the rectangle class is going to be in its own file here. And I'm just going to mimic the rect functionality from the canvas context. So it will be defined with X, Y, width, and height like this. And then set these attributes inside the class like so. It's best if you do use rectangles for something like drawing them and they have a way of being defined. If you don't have a clear reason to use some other way of defining them, then stick to the same so that the code is more consistent everywhere. And then draw. It's the method that we will use to draw this. And I'm gonna use a blue fill color and fill rect this time. I like to do this change because if I draw them as they were before, I can't say for sure when I refresh the page eventually if the new code is working or not, or maybe it's some cached version of the old code or something. So I like to do some kind of small changes every time I debug just to see, is the new thing really happening? And now in index.html, let's use this object. So we'll define these rectangle objects here in an array. It's 0 in the beginning. And instead of drawing them on the canvas here, we just generate rectangles inside of this rectangles array. So I'm going to say rectangles push new rectangle X, Y, width and height, and close both of these like so. So now they are in memory, and to draw them we just call the draw method that we implemented for all of them in a loop here. And now if you save and refresh, you see it looks the same as before, but blue because the new code is really there affecting. Okay, now for collision detection, we also need the player, and I'm gonna define it here at the beginning of the track. So it's gonna be its own object, and maybe it's gonna look like this. So a player getting the x coordinate, I'm gonna set short side divided by 2, and the y coordinate short side divided by 2, and then the radius of the player, let's say a fraction of the short side. And the player should also be able to be drawn. So after drawing the rectangles so we can see it, we draw the player on top of them. And this is now a new class that we need to implement, and I'm going to do it in its own file, player.js, in a similar way as before, but this one has just 3 parameters in the constructor, x, y, and radius. Let me set these as attributes of the object and draw on the context. We begin path, and I'm using the arc method to draw an arc at x and y with the radius, and I want a full circle, so starting at 0 degrees and ending at 360 degrees. But in JavaScript, we use radians for these math functions, and 2 pi radians means 360 degrees. Let's make it red and fill. Save and refresh, and here is our player. And now we can begin to check for collisions between the player and this track. And I'm gonna go in index.html and do this here for now. So after our rectangles and the player are defined, we don't need to have them drawn because they're already in memory. We can check is on track. We begin to say it's false, and now we check each rectangle to see if it contains the player or not. So looping through all of them, if one of them is going to contain the player, then is on track becomes true. And I'm gonna log it here so we can see it in the console for now. Now we don't have this contains method. It's something that the rectangle needs to have. And I'm gonna implement it here. Contains player. Now I want that if the circle just touches the border of the rectangle for it to be considered outside. So I want to include the radius in this evaluation. And for that, it helps to think of an inner rectangle where the distance to the outer rectangle is exactly the radius. And just compare if the player center point is within that inner rectangle or not. So I define here some helper variables. Left for the inner rectangle is this x plus the player radius. Right is going to be this x plus this width minus the player radius. Top is going to be this y plus the player radius. And bottom is going to be this y plus this height minus the player radius. And with these, we can do a simple if, where the player x must be greater than left, and the player x must be less than right, and the y needs to be more than top and less than bottom. If it is, then we can return true. Otherwise, it will return false. And actually, you can write this code a little bit simpler by just returning here. Because if we want to return true or false, this expression here is going to be true or false already, and we simply return it and the end result is the same. So if I save this and refresh, open up the console, I can see true here because it's in the track. But if I'm going to go somewhere out of the track, maybe below, I'm going to multiply this by 2. Then I get false. So it seems to work. And I think it's time to have the player move as well. Let's keep it back in the original location. So I will undo this. And to make the player move, we need to consider what is the initial direction that the player is going to be moving in. And you could have this as a parameter, but I'm just gonna hard code it here because I can imagine a game like this where the player always starts to the right and there's no real consequence to that. And the speed is something that I do want to consider as a parameter here. Of course, both of them would be good to be parameters. I just want to speed up this development here. And with a fixed speed and an initial movement direction, we can implement a move method for the player. If the direction is going to be right, then this x is going to increase by the speed, else this y is going to increase by the speed. And we should also have a method for changing the direction. This is going to be quite straightforward as well. The direction is equal to, and now I'm going to use the ternary operator and say, if this direction is equal to right, then change it to down. Otherwise, right. And with these methods here, we can go back in index.html and start animating. I'm going to do it here below generating the track and animate. It's going to be a function that we create, so function animate. And in it, we are going to move the player like so. And then let me align everything inside here. After we do this collision detection, I'm going to start drawing the things. But before that, I have to clear the previous frame so that the new things don't get drawn on top of each other. So let me clear rectangle everything like so. And now to make this loop, we can type request animation frame and pass animate as the parameter. So this will call animate again and again many times per second. Now if we save and refresh, we can see the player moving like that. Let me do this again. And notice something funny here. True, false, true, false. So for some reason here at this intersection, there seems to be a problem with the collision detection because those inner rectangles here are making it so that there's a gap there. And we don't want that. So there are several ways to implement this, but I think my favorite one is to generate these rectangles so that they overlap. So here for each of these, I can say minus the short side. And now this looks a little bit different like this. Maybe I can demonstrate quickly by saying here stroke rect. So they are overlapping like this, and that means that those inner rectangles are also overlapping, and this is just a transition from true to false now when it really exits the track. So it's good. And if you want the same configuration from previously, let me undo this because I liked blue. If you want the same configuration from previously, just increase this by 50 so that now everything looks as before. Now I want to control the player, so tapping on the screen should change its direction. Let's do it here before animating. I'm going to add an event listener to the canvas for pointer down and the simple callback function where we ask the player to change direction. Save, refresh, and now I can change its direction. And looks like I'm doing pretty good. Ah, okay, not that good. This code is a mess. You can see here very many things happening in the main function where everything should be really, really clear what is going on. And some things are clear now because we just wrote it, but somebody new watching this is going to think, what is this, and what is this, and what is this, and what is this? Many different things. And one reason why we have this problem is that the functionality of the track, it's not extracted as its own class. So everything to do with generating the rectangles and drawing them and checking for the collisions is a responsibility of the track. And we can also extend that with more code because now the track ends here, but it should be infinite. We can't really generate infinitely many rectangles here. They need to somehow update automatically as the player moves. And adding that kind of logic here is going to make it even more complicated. So let's think of that track object. And I'm going to want to generate it like so, a new track. And the parameters are going to be these parameters from here. So the left and the top where it starts, and then how many rectangles we want it to have in the beginning, and then the short side and the long side. So this should generate me a lot of things here, and then I want it to be drawn here. So before drawing the player, draw it there. So two methods, the draw and the constructor. And we also want here to check if the player is on track. So after it moves, if the track contains player, we can return. So instead of logging, I will just return here and the animation will halt. So let's start implementing this object that has these properties. I'm going to have it in a separate file here, track.js, a new class. The constructor has the left, the top, how many, the short side, and the long side properties. And now let's set these as attributes of the object so that it knows what it's like. And this number is something that I'm going to use to generate the rectangles, but I'm not going to store it as an attribute. And the way I want to generate the rectangles is by extracting the function for adding one single rectangle and using that. It's going to be helpful when we make the track dynamic so that it adds more rectangles later, and we can just call that individual function. So the rectangles are going to be now here as an array, and the index is going to be what we use to count how many we need. While this index is less than num, we will add rectangle. And this function is going to be a method here in the class. And the functionality for it, we have it already. So it's going to be this one right here. We don't need the loop. We just take this inner part. I cut it so it's in my clipboard. And I don't need this code here. And also these rectangles will go away. So back here, I just paste and use this index instead of I because I doesn't exist. And all of these seem to require this, 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 this rectangles, and the X and Y are now left and top. So let me just copy x, and x becomes this dot left, and this dot top, we replace y with that. So this should work, but we are not done. We also should increase this index somewhere when we are adding a rectangle. I believe we can do it here. Maybe this is a better place. It makes it read better that the index is indeed increasing. Otherwise, you're wondering where is it going to increase and is this going to be an infinite loop or not? And then we can continue with the contains method. So contains player, and we already have the code for it here, this one. I paste it, rearrange it a bit, and this dot rectangles here. And I believe here we can just return is on track. And finally, the draw method. So the draw method, given a context, we take this code from here. And inside I paste it, and I need this dot rectangles again. Otherwise, I think we are ready to test. Now it stops because we are not logging that thing anymore. We are just removing the animation loop. But other than that, all the functionality is still there, so we didn't really change anything. But what it did change is the code structure. I mean, look at this index HTML. Setting the size of the screen, defining the properties of the track, generating the track, generating the player somewhere, adding the listener for how to control the player. And then in the animate, we move the player, we check if the track contains it, and if the code continues, we start drawing the stuff. So clearing everything, drawing the track, the player, and looping. I don't think it can get clearer than this. Probably you guys know how, and I'm gonna get a lot of comments, but anyway, it's much better than before, and if somebody new is going to read this code, they are not going to have such a hard time with it anymore. Now, let's make this have that layout that we go upwards. So I'm going to do some canvas manipulation. Let's go here below clearing everything, and I'm going to save and translate to the center of the screen. Like so. And after we do the drawing, we restore so that this modification doesn't persist and translate again and again and again, offsetting again and again and again on each frame. Now, if I save and refresh, we can see the one translation to the center of the screen. So now our 0, point is here. And we also need to rotate this. Like if we go here and rotate around this new center point by -12 pi, is going to give us this. So we rotate it by -90 degrees, but we need 45 degrees more. So we can do -3 pi divided by 4. And now we have this, and everything still works because the collision detection for those axes aligned rectangles are still the same. The axes just shifted a little bit. Now the player is going off screen if you do a good job, and that's not good. We want the vertical location to be kept track of. So I'm going to also translate by minus the player x and minus the player y. And now it looks like this. Starts to feel really good. But the track ends and looks like I can win this game. So I'm losing now because the track doesn't go on forever. And if I add many rectangles here, there's a problem because we can't fit infinitely many rectangles in memory. We also need to remove the bottom ones. So if you think about the data structure, like adding things on one side, removing things from the other side, that's a queue. And I'm going to go in the track and implement here a method dequeue rectangle. It's removing the one in the beginning, but dequeue is common terminology and it says what it's doing better than just remove rectangle, right? And now we want to also have the track adjust to the new player's location. So I'm going to say adjust for the player like this. And in the track, we need another method here, adjust for the player. And the logic is going to be that I'm going to find the rectangle in which the player is in. And if it's more than half, I'm going to start removing and adding another rectangle so that it's always, the player is always in the middle of this track. Now, for that, I'm going to loop using an index like this. And I take the rectangle at the index. If the rectangle contains the player, we already have this method implemented. And if the index is greater than halfway, I'm going to dequeue rectangle and also add a rectangle. And I can return here because it saves some processing. We don't do this loop all the way. Now, add rectangle. Let's use this new terminology. I'm going to right click, rename this as unqueue rectangle. So it renamed it everywhere. And if we save and refresh, I died. Okay, we can see something happening at the top. Right. This index stays 10, I think, so we actually need to increase it here for this operation to work properly. Otherwise, we saw what happens. It adds rectangles only on one direction. So let's, oops, try again. Okay, and if I zoom out a bit, oh, I crashed. We should see also the removing of the rectangles happening at the bottom. Okay, so now you can play as much as you want. But I want this to be larger, and we can do that by going back to index and changing these default values, maybe setting short side to 100 and long side 300, let's see. Okay. And maybe we can use a higher speed. So I'm going to define the speed also here. 4 this time. X and Y don't really need to be changing anymore. And the speed, I'm going to pass it here as the last parameter to the player. Now save, refresh, okay. Now it's more of a challenge. Of course, those rectangles could be different, changing the short side and long side from these default values in the beginning, because now it just becomes a kind of a timing game. Like you always click after a fixed amount of time and it's gonna work forever. So it's not really a challenge in this way, but changing the short side length and the long side length is going to make this challenging, and I hope you're gonna do this.